All right, good morning, guys. Welcome to day two of graphing rational functions. All right, so if you remember from yesterday, all right, we were finding the vertical asymptote, then we got to find horizontal slant and whole, x-intercept, y-intercept, and symmetry. We're going to do the same thing today. Only difference is we're going to introduce the third possibility of what could happen. All right, now I call these case one, case two, case three. You don't have to memorize what case they are. You just have to know what happens when the degree is larger on the bottom. That means you have a horizontal asymptote at y equals 0. If the degree is same on the top and bottom, that means you have a horizontal asymptote that is equal to the leading coefficients once they're simplified. And then the third thing is if the degree is larger on the top. All right, we didn't do any examples of that. We didn't do any examples of that yesterday, but that's what we're going to do today. All right, so first we're going to look at number 8. All right, and if you notice for number 8, right away you have the degree is larger on the top than it is on the bottom. All right, now what I didn't really mention this yesterday. I forget the examples if it came into play or not. But what I would do is before we even start doing the vertical asymptote, horizontal asymptote, x-intercept, y-intercept, all that stuff, all right, is make sure you can't simplify this at all. All right, if you notice, x squared minus 9, which I think most of you would recognize this, is that x minus 3 times x plus 3 is equal to that. All right, so we just write it that way instead. So what I would hope you would also realize is that I could cancel out the x plus 3's, which leaves me with x minus 3. All right, now, since we had a case to start where the degree was larger on the top compared to the bottom, we have our third case. Now, one of two things is going to happen. It's either going to be a whole or a slant asymptote. The first thing you see here says whole, all right? If a factor cancels out on the top and the bottom, all right? If that is the case, we have a whole. Well, if you notice, we had a factor cancel out, x plus 3 on the top and the bottom. So what we're going to have is we are going to have a whole, all right? Now, it doesn't say it here, but on your worksheets for your homework, it will say HA. It'll look like this. We'll have HA. It'll have a slash. They'll have an SA. And then the third thing will say whole. All right. In this case, we have a whole. So you would circle whole. All right. And we'll talk about what that means in a second. All right. So we no longer have a rational function. We now have a linear function. We just have x minus 3. So the graph of x minus 3, it's linear, which means we're just going to graph a line with a hole in it. All right. Excuse me. Which means since we no longer have a rational, we no longer have a denominator, we don't have a vertical asymptote. There is none. All right, a little slash there. You can write none, whatever you want. There is no vertical asymptote. All right, there is no vertical asymptote. Now, there is a hole. All right, the hole is going to occur at a point. All right, the hole is going to occur at a point. And the way you figure out what that point is you are going to whatever value, what is the factor that canceled out? It was x plus 3. What makes that equal to 0? Negative 3. That's going to be our x. That's where the hole is going to occur, at negative 3. All right, at x equals negative 3. How am I going to get what y equals? You're going to take this and plug it into whatever's left over. So negative 3 times negative 3, I'm sorry, negative 3 minus negative 3 is negative 6. All right, so once again, where do we get this point from? We take the factor that got canceled out, which was the x plus 3, x plus 3. You set that equal to 0. Whatever that value is, which in this case was negative 3, that's where this negative 3 came from. To get this y, we plug negative 3 into here. Negative 3 minus 3 is negative 6. So basically, what would have been your vertical asymptote, that's what the x-coordinate of your hole is. All right. Now, to find your x-intercept, well, you just set this equal. You would just set this equal to 0, and you would get 3. So at 3, comma 0 is our x-intercept. And our y-intercept is going to be, well, I just plug 0 in for x. That's going to be negative 3. So at 0, comma, negative 3. So all the same steps that I used to follow, right? X-intercepts at the top equals 0. Well, the top is x minus 3. So x minus 3 equals 0, we get 3. That's why it's at 3, 0. The y-intercept, plug in 0 for x and simplify. Negative 3. Plus, this is a line. B is our y-intercept, which is negative 3. Right? So you're just going to graph those 2 points. All right? Let's go ahead and get a different color here. Orange. All right? So if I graph that, say that's at 3, put a point there. There is negative 3, put a point there, and we make a line. Try to make a straight line. All right. Now, the only thing you need to graph is the hole. All right. And roughly the hole is right there. All right. At negative 3, negative 6. So it is a line with a hole in it. All right. It is a line with a hole in it. All right. So just to recap that, we could tell, I'll just erase all this real quick. By just looking at the function, we know it's going to be the third case, right? Because the degree is larger on the top, all right? The degree is larger on the top than it is on the bottom because 2 is bigger than 1. So it has to either be, there's no horizontal asymptote. It's either a slant asymptote or a hole. And the reason it's a hole is because when a factor cancels out the top and the bottom. So x squared minus 9 went to x minus 3, x plus 3. All right, cancel that out, and we are left with just x minus 3. But since a factor canceled out on the top and the bottom, that's why it's a hole. To figure out where the hole came from, whatever factor canceled out, which was x plus 3, we set it equal to 0. We got negative 3. That is where that negative 3 comes from, right here. That's what makes that equal to 0. We then plug that in for x, which is negative 3 minus 3, which is negative 6. That's where we get the point from. X-intercept, y-intercept are the same thing. This is what you graph, and this is a line. It's linear, right? That is a line, all right? So we end up with a line with a hole in it, all right? All right, so let's go and check out 7, all right? So looking at 7, what we have here is we also have a situation where we have the degree on the top being bigger than the bottom. 2 is bigger than 1. All right. So that means there is no horizontal asymptote. It's either a slant or it's a hole. Now, if I were to factor this, and if you wanted to switch this around to make this negative x squared plus 4, you could, but it's like 2 minus x, 2 plus x, right? Is anything going to cancel out with x? No. So therefore, we do not have a hole. All right. What we have is we have a slant asymptote. All right. So if the nothing factors out, what we're going to do is you must divide the top and the bottom to find the slant asymptote, and we'll do that in 1 second. All right. But since this doesn't cancel out, we do have a vertical asymptote. And if we remember, vertical asymptote, we just have the denominator equal to 0 and solve. So the vertical asymptote is that x equals 0, right? One thing makes that equal 0 is 0. All right, so now we have our slant asymptote, and it says to divide the bottom into the top. Now, the easiest way to divide, if long as this is a linear term, meaning it has a coefficient of 1, an exponent of 1, we can do synthetic division. All right, in case you forget, synthetic division is you put whatever makes this equal to 0 in the box. Well, that's easy. It's just 0. Now remember, this is actually negative x squared plus 4, right? Negative x squared plus 4. So it's a negative 1, 0. Why is there a 0 there? Because there's no x term. Then there's a 4. All right. So when we do synthetic, you bring down the first term, negative 1. Then you do negative 1 times 0, which is 0. You add those, 0. 0 times 0 is 0, and you get this. All right. Now, real simple. You don't care about the remainder. All right. You don't care about the remainder. What is left here? That's your constant. this is your coefficient of x, all right, which means my slant asymptote, so remember this is a slant asymptote, is y equals negative x, all right? Constant, there is no constant there. That is my coefficient of x. So it's y equals negative x. All right. The line y equals negative, it's a line. And that's the reason why it's called a slant asymptote. It's a line just like a horizontal, but it's not horizontal. It's just going to be a line. You'll see that in 1 second when we do that. All right. So now, once we've done that, we continue to do what we've done before. We have our x-intercept, which means we set the top equal to 0. All right. Well, setting the top equals 0, 4 minus x squared is 4 equals x squared. Take the square root of both sides and you get plus or minus 2, which means the x-intercept is plus or minus 2, comma, 0. All right. Then for y-intercept, you plug in 0 for x. Well, if I plug in 0 for x, what happens? You get 0 in the denominator, which means you can't have that. So there is no y-intercept. Also, anytime the vertical asymptote is x equals 0, there will never be a y-intercept. All right, never be a y-intercept. All right. So now we just, like we did yesterday, we just go through and graph each of these things. All right, so vertical asymptote, x equals 0. All right, so that is the y-axis. Okay, bad dotted line, but you guys get the idea. Now, slant asymptote, y equals negative x. Y equals negative x is a line with, goes through the vertex with the slope of -1, which means I go up 1 to the left 1, it's right here. If I go up 1 to the left 1, it's there. Or I can go down 1 and to the right 1. So it is a line with a negative slope, a slope of -1. So you can see, I put a dotted line there, you can see why it's called a slant asymptote. It's on a slant. All right, it's on a slant. Now, before, when we had a vertical, right? So let me just come down here and draw something for you. Before, if I had a vertical and one horizontal, wherever it was, we always drew the curve, one to the right, maybe one to the left, whether it's up there or down there, one of those things, right? Well, now we have the same situation. It's just that instead of having a horizontal asymptote, we have a slant asymptote. But still notice, there is 1, 2, 3, 4. There is 4 quadrants. We're going to put our curves in. One has to be to the right of the vertical asymptote, so it's either going to be here or there. One has to be to the left. It's either going to be there or there. Okay. Now, how I know where to put it? Well, we have a couple points here that are going to make our life hopefully a little bit easier. Right? So I'll use blue. 2, 0, -2, 0. Well, fortunately, they are both in different quadrants. So it must go something like this. Notice how it's getting closer to the asymptote, but not touching. And the other one goes like that. All right. Notice how these, do you guys remember vertical angles from geometry? Like this angle and this angle vertical? When you have a slant asymptote, if you have one curve over here, the other one is always over here. If I had a situation and I had this going on, there's our slant asymptote. If my curve was here, guess where the other one's going to be? Right there. Always works. If the curve is here, the other curve is going to be there. Always, always works out. All right. All right. So if you look at this, do you think there's any symmetry in this? All right. And the answer to that would be no, because if I rotate this, it's not symmetrical about the, you flip it, it's not the same graph. And if you rotate 180 degrees, it's not. So there is no symmetry for this particular one. Okay. All right. So there's an example of a hole and a slant asymptote. All right. So just to practice, let's want you guys pause the video right now in a second and try number 9, all right, before I do it to see if you can get it. But looking at it right away, you should notice that the degrees are the same. So this is the case where they're the same on the top and bottom. So go ahead and try to do that. Pause the video, try to do that on your own. And then when you come back, I'll go through and do it for you guys. All right. So if you notice here, the x squared minus 4, we can right away just do this to x minus 2, x plus 2. Now, obviously nothing cancels out with x squared, and it shouldn't because these degrees are the same, so I shouldn't have a whole anyway to start with. All right, so now I go through my progression of, all right, well, how do I find the vertical asymptote? Set the denominator equal to 0. So you just kind of have to know when you see a vertical asymptote, all right, that means set the denominator equal to 0, which is, in this case, it is 0. Now, horizontal, slant, or whole. The degrees are the same. That means I take the leading coefficient, 1 over 1, which is 1. All right, so I get y equals 1. X-intercept, you set the, to go over here and just look, x-intercept, set the top equal to 0 and solve. All right, so when I set the top equal to 0, I actually get 2 and negative 2. So it's plus or minus 2, comma, 0. All right, y-intercept, plug in 0 for x, so I get 0 and 0. I get negative 4 over 0, which is can't have, so once again, it's none. Another example of vertical asymptote is x equals 0. You can always, the y-intercept is always none. All right, so let's go through and graph those things. We have a vertical asymptote at x equals 0. We have a horizontal at y equals 1. All right, we then have x-intercepts at negative 2 and positive 2, 0. Now, we're fortunate that they are in 2 different quadrants, so we are good. We know exactly where to draw the curves. If we did not know where to draw the curves because we didn't have an x-intercept or a y-intercept, you could always just plug in a point to the right of each right and left of each vertical asymptote, and that will tell you where the curve is. For instance, if I plugged in 1 into my original, 1 minus 4 is negative 3, all right, over 1, which is negative 3. So 1, negative 3, I would know it's down here. That would be my curve. All right. Same thing for this. We were fortunate in the slant asymptote one where we knew the 2 points were in both curves. All right. If I didn't know where one of them was, we can use my trick that I showed you before. That's always the vertical angles of each other. Or you could just plug in a point. All right. And see where what little quadrant I'm calling them quadrants. But hopefully you guys understand what I'm talking about, how it's broken up into 4 little sections, all right, where you're going to draw your curve, all right? So hopefully you got that one. All right, let's try to find one more that has a degree bigger on the bottom. I'm sorry, yeah, degree bigger on the bottom than is it on top. So we can practice the slant asymptote or a whole problem. All right. So last example that we're going to do is, this is actually from your homework that you guys are going to get in a second, that you guys are going to start. And it's number 1 here. All right. So take a second and pause the video and try to do number 1 on your own. All right. Okay. So we have another situation here where the degree is larger on the top than it is on the bottom. All right. So this is a case where horizontal asymptote is at the window. X squared minus 1. You can factor that. It is x minus 1, x plus 1. However, nothing cancels out. There is no x plus 2. So this is not a hole. All right. We're going to have a slant asymptote, which we'll get to in a second. All right. All right. So for a vertical asymptote, we're going to set the bottom equal to 0. And we get x equals negative 2. All right. So now for the slant asymptote, this is a linear term. We divide, but we do a little synthetic division. Well, what makes the bottom equal to 0, or the x plus 2? Negative 2. So that goes there. What's the coefficient of x squared? 1. There is no x, and then the negative 1. So we bring it down. We got 1, negative 2. That's negative 2. I stop here because the remainder doesn't mean anything. So remember, it's the remainder, constant, the coefficient of x, which means my equation, which is always going to be y equals, it's going to be a line. Y equals x. If that was a 3, there'd be a 3x. But it's a 1, so that's why it's just x, minus 2. All right? That's going to be our slant asymptote. X-intercept. Set the top equal to 0. Well, there's 2 of them. Plus or minus 1, comma 0. Right? Because 1 makes this equal 0, negative 1 makes it equal 0. Y-intercept. Put zeros in for all the x's. You actually get negative 1/2. So you get 0, comma, negative 1/2. All right? So we're going to go through and now graph these. So x equals negative 2. Let's see, 1, 2. So there's our vertical asymptote at x equals negative 2. All right, our line y equals x minus 2. So that's going to start at negative 2. It's going to go up 1 to the right 1, up 1 to the right 1, or you go down 1 to the left 1, down 1. So it looks something like this. All right, and there's our slant asymptote. Let me just bring this down. So just so you guys can see, we have 1, like this area here. We have an area here, 2. We have 1 here. We have 1 there. Our curves, we're going to have a curve in either 1 and 2 and a curve in 3 and 4. Remember, if I have a curve in 1, it means I need a curve in 3. If I have a curve in 2, all right, it means I need a curve in 4. All right, so everyone understand that. You don't need to draw those in. I just want to show you what I'm talking about when I talk about these curves. Now, plus or minus 1. Look what happens here. 1, 0 is there, negative 1, 0 there. They're both in the same thing. They're both in 1. So it goes down a little bit, and then it comes back up. All right, now, I don't have any other points. So if you remember, what should happen is it's always the one that's vertical angles of it. So this one, it should be in 3. If you don't remember that, not a big deal. If you were to plug in any x value to the left of this asymptote, so since the asymptote's at negative 2, negative 3, negative 4, negative 5, whatever it may be, if you want to plug in negative 5, let's just pick negative 5. All right. Actually, I'm just going to pick negative 3, 1 to the left. Keep the number small. Negative 3 squared is 9, minus 1, which is 8. So I get 8 on the top. Negative 3 plus 2 is negative 1. So I get negative 8 over negative 1, which is negative 8. Well, where's negative 8 going to be? That's down here somewhere. And I should know that because it makes sense, because if the curve's in this area, it has to be in that area. You do not need to graph that point. You just need to do it just like that. All right. So there's a couple examples of a slant asymptote, a couple examples of a hole. Do your best to do the homework. All right. I think there's like 10 or so problems on this worksheet. Do the best that you can. What I'll do is sometime today I will put up a video explanation of all of the homework problems. All right. So if you have some, after you watch The notes, remember, you can always go back and rewind and go through another example if you weren't quite sure what something happened. Then look at the explanations of the homework. If you still have questions, feel free to contact me through Classroom or through email, and I'll get back to you guys as quickly as I can. All right. We will be doing more practices tomorrow or the next class we meet, depending on what class you're in. The next day that we have algebra, we're not going to be learning anything new. It's just going to be more practice with these types of problems. All right. So hopefully day by day, you'll start to understand it a little bit more. All right. I hope you guys enjoy the rest of your day, and I'll talk to you guys soon.